Discovery is our dedicated tool to prepare the geometry to be successful in the mesh. We will see different topics together, and let's start with the first one, where we will prepare the geometry by simplifying the geometry. So this geometry, the first thing I would like to do is to replace the bolt by a real bolt connection. So the bolt connection will be a kind of beam element where I will introduce the connection on the top faces and so on. So we have a dedicated feature for that. You just need to select a hole, a cylinder, and we automatically find the equivalent radius. You can define if you need to remove or add to your selection, and select from a bolt list. And automatically you see the 3D representation of the bolt. We have the beam element, and in mechanical you will have the exact connection of the head of the bolt without doing the split. It will be done completely automatically. Another thing you would like to remove are usually the small rounds, the small details. So we can, with the Power Select tool, automatically in one click detect all the rounds in the part or in the models among different bodies. And sometimes when you delete that, when you fill the operation, you have to do that a couple of times. And the reason is because some faces are not detected as a round in this case. So just by adding the extra face to my selection, I can delete again and do the job. If I zoom in specific area, we have some cases where it's sometimes more complex, because you see the geometry there, the round is crossing another face, and I probably don't have exactly the same radius on the top and bottom cylindrical faces. So in this case, with the round command, I can split the round into pieces. So like that, I can isolate the prime, I can easily remove the other part of the round, and now I can focus on the area where I have my problem. Okay. So let's zoom in on this area, and I see I have a lot of details around, and I need to remove these details because I don't need. So let's first make a check, and you see there is a pretty small angle between these two faces, and I don't need to keep this angle, so I need to simplify that. So I can box select everything or just remove the rounds. Okay, I can step by step simplify the geometry, and there I do huge box selection to include all the faces in my selection, and with the suppress key, just delete, okay, and the faces are gone, and automatically extend the faces around. If I really need to keep the rounds I had at the beginning, I can simply select the edges and recreate the round. Okay, just type the value, or I can directly copy the value from an existing round on another part of the geometry. You see, I can just quickly reassociate the value with the up to, and I can directly pick the value of the round on another geometry. And there with a double click, I can automatically propagate my selection to the tangent edges. And the problem is solved. Now I would like to focus on another area on the geometry to show you something, another interesting thing. So in this case, you see you have a lot of small faces with sharp angles and stuff like that. So we have tools to detect that. But what I would like to show is I can simplify that by selecting all the faces together and merge them into one unique face. Okay, so like that, I will drastically reduce the number of node creation during my meshing process, and I will be successful for the mesh in this specific area. I will not have to generate a lot of nodes and elements for nothing. So I told you we have a dedicated tool to detect some specific features, errors in the geometry. So there I need to quickly detect all the holes below a specific size, and you see in one click I can delete everything. I can do that for the logo. We have a dedicated feature to detect the logo, so it could be an extrusion or a depression, and by giving a dimension, okay, I can detect that. This one is to detect a gap between different pieces. Okay, so if I introduce a contact, or if I expect a shared topology, okay, to have a great contact, I need to clean the geometry a little bit. And for that, I can work in this section mode. So I slice the geometry by a plane. And the beauty of Discovery is when I'm in this mode, I can directly replace a selected geometry by another one. So I can replace a cylinder by another one, a plane by another one, and the geometry will be automatically adapted. Another way to work is also to directly pick and drag an edge to make the change. Okay, so my gaps are correctly filled, okay, and if I zoom in this area, you see that correction is done. So there I slice by the the axis here, and if I need, I have a small collision here, and then by dragging the edge, I just explained, okay, I just drag and snap exactly through the other edges, and my contact now is super clean and exactly well defined between the two parts. Among the different tools we have to detect some geometry issues, there is one especially interesting, is to detect the small faces. So of course you can define the criteria to define what is a small face. It could be based on the surface area and dimensions, on different things. And there I found one, but you see when I look around the model, it's pretty difficult to find it. So I have a red point, so I can easily see where is the error, but it's difficult to access because it seems to be inside the model. So what I would like to show you there is there is a way in Discovery to go inside. With the fly-through command, we can navigate inside the model, inside the geometry, so I can go through the walls, you see, so that's why you see a different color, just to indicate if you are on one side, on the other side of the material. And there I identify the problem, okay? I see the problem, there is this edge, there is something pretty small there, an extra edge there, and it seems that the two rounds seems to be equal, but there is a pretty small detail. So I can select both, and as I did previously, I can merge the two faces together. Okay, and my problem is solved. Okay, so literally I'm inside the model there, and if I rotate a little bit just to see what I can see around, and you see there I have another mistake, I have another small face, and I could check that. Okay, so same way to work, I select my different faces, okay, and then I can merge all of that together. Okay, just one click and problem is done. Okay, so it's pretty interesting to be able to navigate inside the model, to apply some correction, to remove some small edges, and to clean the geometry as expected. Okay, because all of these steps will drastically reduce the errors and will facilitate the meshing process afterwards. The last tool I would like to show you is a split edges tool. So we can detect in one click all the areas in the model where the edges are split. So the reason of that is because during the mesh process, it will create a node at this specific location. And if you have two pretty close split, it will create a pretty small element size, and it's probably not expected. So it was a quick tour of the different tools we have to prepare the geometry to help you to clean the model and to perform a great mesh in Mechanical. Second topic is about thin structures. So in this case, we need to simplify the geometry by extracting most of the time the mid-surface to be able to perform a 2D mesh, a shell mesh in Mechanical. So first of all, I just need to isolate the different bodies I need to preserve for my study. So show height is not enough. I can select per body which one will be transferred in Mechanical, okay, whatever the visual state. So the operation of the mid-surfacing is directly done by a dedicated command we have in Discovery for mid-surfacing. And we can select, you see, with the different colors, green and blue, the top and the bottom. And I can decide not to extract the mid-surface. In this case, the surface is detected based on the two faces selection, and based on my selection, the thickness is automatically recognized and I extract that on the same body. But I can decide what I did here. I can decide to extract either the bottom, either the top, to be sure that the connection will be done directly without any offset, manual offset. What I'm doing right now is to use an interval command. So instead of selecting the body one by one to define the thickness, I can just define a range, min and max, and all the bodies having a thickness in this range will be automatically managed. Okay, so you see there I have some gaps. Okay, that's normal because by extracting the mid-surface I created some gaps, but we have a tool, and in one click, so everything is recognized in the red area, and I can just by selecting the red area extend or trim the surfaces or a portion of the surface to be sure that the connection is done. What I'm doing here is not just an extension of the surface, but I need to translate the full face. So there I can snap directly, drag and snap up to the other one, and I can do exactly the same with the edges here. So in this case, I can just look around. Everything looks great and correctly connected. We will see that just after with a double check. But let's see what happened on the other side. On the other side, I have this internal shape with a kind of S shape. And of course, whatever my choice, top, bottom, middle, I will never have a connection. It's not possible. Okay, but no problem for that. With my pull command, I can directly pull and go up to and snap to the other faces. So like that, I can ensure that my mesh will be coincident and will be perfectly done. One more, and yeah, everything is done. So now I need to share the topology. So for that, let's use the tool share topology, where I can visualize with exactly the same colors as in mechanical that everything is correctly shared. And I'm sure that when I will transfer the model to mechanical, that I will not manage the contact, but I will have a common mesh. Next topic is about partial mid-surface, but what is interesting here is I need to keep the history tracking to drive my parameters and to make some changes. So there I see some faces with a color, with different color, and I need to extract the mid-surface only for these surfaces, for these areas. So let's clean the geometry. You see there I'm removing some rounds. And what I did, I activated my history tracking. So what is interesting there is for each feature I'm doing, I keep the history of the feature. I can reedit the feature. This is what I did with my first round. You see there I created round one, and now I create the different rounds so that I re-edited the geometry and just I validate the selection, replay my history, and everything is rebuilt with a new selection. Okay, so and this model is a little bit particular. I cannot apply directly the mid-surface. So what I'm doing here is I just copy, paste the face. I remove with an extrusion, I made the cut, and then I show the faces I duplicated. I just need to make an offset, so I measure the distance. Okay, in this case, the thickness is 3, so I make an offset of 1.5, and I associate on the surface body the thickness. And this parameter will be transferred to mechanical. Okay, so this is done for the first rib. So let's do that for the second one. So the second one, I'm using the mid-surface tool. So you see the mid-surface extract the mid-surface, but I'm still preserving the original body. And I will use this mid-surface as a reference to pull my selection, to pull my different faces up to this mid-surface. So like that, I'm removing material on one side, and I will perform exactly the same operation on the top. So like that, I completely remove the solid part of the body here, and I just have different faces. I'm still using the extend tool I used previously on the previous model to automatically re-extend. It could be done with the pull command as well. Let's perform exactly the same operation here. I don't take time to remove the rounds in this case because I know with the pull operation the rounds will be removed automatically. You see that. And create the offset. So I measure on the other flange the thickness and just make the offset and reapply the thickness. What is interesting here is that something that can happen, that the surface you have is not exactly connected with the different bodies. So I can just pull the edge up to, and there is a quick tool here. You directly press enter, we directly go up to this body. And there I can delete, with the suppress key, I can delete the edge and automatically my surface will be extended. So my job is done, pretty easy. Okay, but what is interesting here, I don't want to waste more time because we already spent time on the mid-surface in the previous example. What is interesting here is, if I show the history tree, you see that all the operation, all the steps have been recorded. So if I switch back to the first one, where the model was not modified yet, nothing was done, I can just pick my faces and bring a change. In this case, I would like to change the angle, make a rotation. So that's interesting because I keep the freedom of the direct editing to manipulate the geometry as I want. And at the same time, everything is recorded, and I can pick an operation, select a parameter, decide this parameter will be transferred to Workbench, and I can directly make a change here and rebuild the tree, and you see my rib, the angle of the rib has been modified. I can make another one in the other direction, and in second, everything is updated. For the next topic, I would like to start from mechanical result. In this case, I have a topology optimization based on the lattice density. So you see the result in mechanical here with the different colors. And the goal is to export that or to reuse this result. So it's not, I mean, that's an export, but that's a link. So everything will be updated and maintained linked. So that's the most important thing. From the schematic, I can directly open Discovery. And of course, in Discovery, I will have the result, but all the data I have I added for my studies, the original model and the optimized one. Because it's a lattice density, I have to create the lattice directly in Discovery. So we have the tools with all the features and all the different shape of lattice. directly inside the facets command in Discovery. And I don't have to define all the parameters because I directly have this option. So when I transfer the geometry, I automatically transferred the information about the lattice and how the lattice is spread. So I simply need to select which shape of lattice I need to use, validate some parameters I can still define, for example, the thickness of the shell, and I remove some faces just to view inside there. And the result is done. So first of all, it's pretty quick to create. As you can see, it's not the same lattice, but not with the same thickness everywhere, and I can bring some changes. What is interesting is now let me recreate exactly the same thing, but I will activate the history tracking, the same feature we saw on the previous model. So by combining both, okay, I will perform the lattice, but now if I open the operation recorded, the feature recorded, I have all the options from the lattice exposed. So each option can become a parameter, can be driven from the Workbench or through OptiSlang, why not? And I can directly make the change, of course, the shape of the lattice. Okay, it could be a diamond, it could be whatever the shape you expect, and rebuild, and you have the result. For the last topic, I would like to share the one more thing with Discovery. So the goal is to create a simulation directly in Discovery. So you can reuse the result of a TopoOpt, recreate a surface automatically in Discovery, okay? But there, I would like to show you that it's doable if you want with Discovery to create a simulation. So this part is quite complex in terms of patches and complexity of the patches, but we discover all the tools to prepare the geometry. So there, directly in Discovery, I can apply some boundary condition. And by the way, all the pre-processing I'm doing right now can be directly transferred to Mechanical. So I could apply the boundary condition, the materials here, the contact definition in Discovery, and when it's done, I can send that to Mechanical, and automatically I create the study with the boundary condition, and I just need to mesh and to run. What I'm doing here is after my boundary condition definition, so you see I'm using something basic like a sliding contact fixed force. I'm creating here another force with the remote point. Okay, so you have all the flexibility of the selection from Discovery, so that's pretty nice. You have the head, so all the options close to the cursor, so like that you can work properly, and it's super easy to access to all the features around the mouse. Okay, and what is interesting is when everything will be okay, I will have to press on run, and the result of the simulation will be calculated in live without any video editing on my computer. So I just double check that all my boundary conditions are set, and I press solve. And look at that. In seconds, my result is there. My problem is solved on my graphic card. So I'm using all the cores. In my case, on my laptop, I have many thousands of cores on my GPU, okay, and that's the reason why it's so fast. I'm not wasting my time to write the result on the disk, to create temporary files and stuff like that. That's the reason it's super fast. But there, I would like to go one step further. I would like to activate the topology optimization. So what you see in pink is are the protected area. Everything can be modified. I can set some manufacturing constraints and other different targets for the optimization. And you see step after step. You see the geometry changing. You see the result of the TopoOpt. You can stop it when you want. What is interesting here is you can, in seconds, let's say minutes, you can have a guess of what the result will be. And if you push further by using another solver algorithm, or if you need to deal with more complex physics, you can still transfer it to Mechanical and continue the job in Mechanical. So through these different models, examples, I wanted to show what Discovery can bring every day for you, how the tool can be used to prepare the geometry or to create the geometry from scratch, whatever the source, by keeping the link with Ansys Mechanical, or by keeping the link and the connection with any other product in the Ansys portfolio. And the beauty of Discovery is to be able, in the same interface, to run a simulation.